Okay, let's recall some concepts of the rectangular coordinate system that we've seen in the past in terms of graphing. Rectangular coordinate system. Let's recall that this is a two-dimensional system here. So points in this system will have an x-coordinate and a y-coordinate. Let's recall that. But first of all, the rectangular coordinate system is formed by intersecting a vertical axis and a horizontal axis. Right? That vertical axis or vertical line is called the y-axis. The horizontal axis is called the x-axis. Right? Now the points where the y and the x meets, right in the middle here, is called the what? Let's recall that. Origin. Alright, right there, sorry about that. Origin. Alright? And any point in this rectangular coordinate system, as I mentioned, is going to have two numbers. An x component and a y component, namely an x coordinate and a y coordinate. Alright? Now the origin then is going to have what? Coordinate 0, 0. The first number is the x coordinate, second number is the y coordinate. Alright? So let's recall these concepts a little bit then. Alright? Now the rectangular coordinate system, you can see if I have the x and y intersect like that, it's going to divide into 4 different quadrants. Alright? Here is the first quadrant, let's recall that. Here is the second quadrant, here's the third quadrant, and here's the fourth quadrant. Now, what do these quadrants imply in terms of the points on them, or the order of pairs? Well, for example, points in the first quadrant have what? Positive x and positive y. Alright? So any point on here, let's call this point P, is going to have positive x and positive y. So think plus and plus here. Right? A point here, let's call it Q, with a different x and a different y. It's going to have what? Negative x, but positive y. So x coordinates here are what? Negative, y coordinates are positive. And down here, let's call it point S, or point R. Let's call it R first. Alright? And again, the x coordinate and the y coordinate, well, they're both what? Negative in that case. Alright? So both x and y are negative numbers in the third quadrant. And in the fourth quadrant, let's call this point S, x and y. Alright? X will be what? X will be positive, but y is going to be negative. Alright? So these are the implications of points in each of these 4 quadrants. Right? But again, I'm not going to spend too much time on that. The thing I want to cover here is going to be what we haven't seen in the past, and that is, if I give you 2 points, can you find the distance between the 2 points, and can you find the midpoint, the middle point between those 2 points? Right? So let's talk about those 2 concepts, distance and midpoint. Right? So let's go ahead and plot these 2 points here, if you will. So let's go ahead and let's call point plotting in the rectangular coordinates. Let's go ahead and plot the points. Let's say 1, 2. All right, and the point 4, 6. Alright, so let's go ahead and draw the rectangular coordinate system grid nicely here as best we can. So here's why a little bit tough to draw with the sketch pad here, but we'll do the best we can. Alright, here's the x coordinate. Alright, so let's make a few marks here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. I have to go out to. Alright, so the first point, 1, 2, is going to be, we plot these points counting from the origin. So therefore 1, 2 will go 1 to the right for positive x is being 1, 2 up for y being 2, so 2 up right here. So this is the point 1, 2. Alright, 4, 6, just go out to 4 here then, and 6 up here. So this is the second point. Alright, so let's find the distance between them. So let's go and find the distance. Let's find the distance between these 2 points, 1, 2, and 4, 6. Well, that means what? If I were to connect these 2 points into a line segment, let's see if I can do this correctly here with the sketchpad. A little bit tricky again. Sorry about the sloppiness there, but sketchpad is pretty hard to draw lines here. All right. Anyways, what is the distance between these 2 points? All right. Now to calculate that, as you can see, if I sort of extend this horizontal a little bit, alright, using dashed lines, and this vertical a little bit using dashed lines, I get what's called a right triangle. Right? And with the right triangle, we can apply Pythagorean's formula to this triangle. Let's recall what that is. In other words, if I have a right triangle setup, all right, which is what I have here, all right, right triangle, I can calculate this this length right, this diagonal right here, if I know the horizontal distance and the vertical distance. Let's call that A, call this B, and this will be C, as you might recall. And as you might recall, Pythagorean's formula says what? A squared plus B squared will be equal to C squared. All right. So we've seen that in the past somewhere from geometry, but this is the formula you want to use to calculate the distance between these 2 points. All right. So how do we do that? Well, first we have to locate the horizontal distance between the 2 points and the vertical distance. Right? How do we do that? Not too bad, right? If you look at from this point, from the first point to the second point, what is the horizontal distance? We'll just count. 1, 2, 3. 3 units. That's 3 units. Let's count how many. What's the vertical distance? Well, from here up to here. Well, 1, 2, 3, 4. So 4 units. So let's calculate C, the distance between these two. This diagonal distance between the 2 points. All right. So use this formula here. So my A is going to be what, 3 in this case. This is my B then right here, 4. Right. So we have 3 square plus 4 square equal to what? C squared. All right. So A squared plus B squared equal to C squared. So 3 squared, you know, let me continue running out of space. That's going to be 9 plus what? 4 squared is 16 equal to C squared. So 25 is equal to C squared. And now if I take the square root of both sides to solve it for C, you see that we get 5 here for square root of 25, or 5 units. So the distance between 1, 2 and 4, 6 is going to be 5 units here. All right. So to find the distance, we're going to use what? The distance, the Pythagorean's equation. All right. Now let's apply the same concept to 2 general points, but I'll put them both in the first quadrant for simplicity's sake. Let me go ahead and clear out the screen. All right. So let's go ahead and let's consider this this problem right here. So let's look at this problem right here. All right. Let's again, I'll put both points in the first quadrant for simplicity's sake. So let's say here is point A. Let's say here is point B. All right. So point A is going to have some x coordinate, we'll call it x1, and some y coordinate y1. Point B is going to have a different x coordinate, let's call it x2, and y2, different y coordinate. All right. So what is the distance between A and B? Well, again, let's connect them first of all, right, like we did earlier, and let's make a right triangle out of it, just like we did earlier. Right triangle. Right? Now, we have to calculate the horizontal distance and the vertical distance between points A and B. But that's not too hard, as you can see, because here is what? x1, essentially. Here is what? x2, essentially, right? Since that's the x coordinate for B. Well, the distance between them is going to be the difference of x2 and x1. So this is going to be x2 minus x1. All right? Similarly, the vertical distance between these 2 points will be what? y2 minus y1, because again, here is a y1 for the point A, here up here y2 for the y coordinate of point B. So the vertical distance between them, the difference of y2 and y1. So y2 minus y1. So again, this is my A, this is my B, and let me call this distance D instead of C. It's the same thing, right? I could have called it C. But anyways, Pythagorean's equation says what? That A squared plus B squared equal to C squared, or D squared in this case, right? So I'm going to get what? X2 minus X1 squared, right? So that's A squared, right? This is my A right here. That's my A, all right? Plus B squared, this is my B, right here. That's my B. So y2, oops, sorry about that, y2 minus y1 quantity squared is going to equal to what? The distance between these 2 points, D squared. All right? So that should be y2 here. Sorry about that. All right? Anyways, if I simply take the square root of both sides to solve for D, as I did earlier to find the distance of 5 units, right? As you can see, the distance between 2 general points is going to be what? This formula right here. So here's our distance formula between 2 points. So let me put a big, giant square root there. So it's going to be x2 minus x1 quantity squared plus y2 minus y1 quantity square, right? So this is the distance formula between 2 points, 2 general points, all right? So if I give you 2 points, then we can apply this formula to find the distance, all right? So here, let's do that. Let's go and look at these 2 points. Let's go and find the distance between these 2 points. Find distance between these 2 ordered pairs. Okay, so first point is going to be, let's make it, for example, 6, -1. And the second point is going to be -3, -2. Alright, so again, just apply this formula. Let's go and find distance. So again, just label these points as x1, y1, x2, y2. So here's x1, y1, x2, y2. Not too bad, right? I just plug the numbers in, basically, right? So the distance between them is going to be 1 giant square root, okay? X2 minus x1, so -3, minus 6, quantity squared, plus y2 minus y1, so -2, minus, be careful, negative sign here, minus parentheses, -1, right? That's y1, right? -1, quantity squared. So again, x2 minus x1 plus quantity squared plus the quantity y2 minus y1 quantity squared. Again, let's simplify this step by step. So we're going to get square root of -9 squared, -3 minus 6, right? Again, this is essentially -2 plus 1 if you do some work there, but that's going to be what? -1. So plus -1 quantity squared. So this will be equal to the square root of what? 81, right? -9 squared. -1 squared is just +1. So this is going to be the square root of what? 82. So it's going to be an irrational number, but nevertheless, it's a positive number. So root 82 is the answer we're looking for the distance between these 2 ordered pairs. Right? Let's go and try another one. See if we could do another one on here. Let's go and look at these 2 points and find the distance here. Again, find distance. All right. So the ordered pairs here will be, let's try -2, 3, -2, 3, and the ordered pair 5, -1. All right. So -2, 3, 5, -1. Again, same thing. Let's label the points: x1, y1, x2, y2. So be careful labeling points. First x coordinate, first y coordinate, second x coordinate, second y coordinate. All right. Again, let's apply the formula. So the distance then is going to be 1 giant square root. Oops. Giant square root there. So again, x2 minus x1. So quantity 5 minus, again, be careful there, -2 or 5 plus 2. You want to skip that step. That's fine, right? But 5 minus -2, quantity squared, plus y2 minus y1, -1, minus 3, quantity squared. So that's going to yield what? Running out of space here, but we'll do the best we can. Square root of, again, that's 5 plus 2, as mentioned. That's going to be what? 7 squared. All right? Plus, that's what? -4 squared, right? -4, -1 minus 3 squared. So this will be square root of what? 49, 7 squared, plus what? 16, -4 squared. So the answer is going to be what? Radical 65 if you add up 49 and 16. So these are the units, again, an irrational number for these 2 points, distance between these 2 points. Right? So hopefully not too bad in terms of figuring out the distance between these 2 points, just applying the distance formula here, right? Let's look at the midpoint formula. How do you find the midpoint? In other words, if I connect these 2 points, let's say A and B right here, what is this point right in the middle right here? Right? So let me clear our screen and draw the picture again. All right, so if I have the xy coordinate here, all right, let's say here's A again, x1, y1 again. I'm not going to write it down again, but yeah. So let's say if I were to connect them, what is this point right here in the middle? So this point here is called the midpoint. This is the point that divides this segment AB in half, basically, right? That's the midpoint. That's the middle point between A and B. So how do you find these coordinates? Well, that's not going to be too bad because the middle is just an average. Think of middle as average. In other words, to find the midpoint of A and B, just simply average the x coordinates and the y coordinates. In other words, the midpoint formula is going to be given as the ordered pair. So again, you remember point A earlier was what? x1, y1, right? and point B was x2, y2, right? Oops, sorry about that. But so the average between them is going to be what? How do you average two numbers? You add them up, you divide by 2. So the x-coordinate for the midpoint, x1 plus x2 over 2, average of the x-coordinates, y1 plus y2 over what? 2, average of the the y-coordinates. So average of the x-coordinates, average of the y-coordinates. This is the midpoint formula to calculate the midpoint between 2 points there, right? So earlier, if I had the same 2 points again, let's calculate their midpoints. Earlier we had what? 6, -1, and what was the other one? -3, -2, right? So -3, -2. So this find the midpoint. That's pretty easy. Just simply average their x and y coordinates, if you will, right? So therefore, the midpoint then is going to be, in this case, x1 plus x2, so 6 plus, so don't minus, right, like we did for the distance formula. It's a little different here, right? So you add them up, average, and divide by 2, all right? And -1 plus -2, average of the y-coordinates, divided by 2. All right, so pretty straightforward, I think. If we work it out, we're going to get what? +3/2 on the first one, and -3/2 for the y-coordinates. All right, so this will be the midpoint between these 2 points. Now we can actually plot these points and see roughly what it looks like. Just let me plot and show you that you should. This is approximately. This is the midpoint, but my sketch won't be as clean. But let's go and try it anyways. All right, so here's y, and here's x. Let's plot these 2 points. So let's see here. 1, 2, 3, 4, 5, 6, as neat as we can. 1, 2, and 3. 1, 2, and 3. And let's see here. 1, 2, and 3. All right. So 6, -1. So here's 6, -1 down here. All right. -3, -2. So -3, -2 down here. So if I were to connect them, or actually, let me not connect them yet. Let me go ahead and plot the 3/2 and negative. That's 1.5, -1.5. So here's +1.5. Here's -1.5. I didn't do it real cleanly, but hopefully see that this is between the 2 points. But yeah, I didn't scale it real well, so I apologize for that. So again, 6 plus -3 over 2. That's +3/2. -1 plus -2. -3 over 2. All right. So again, just average the x and y coordinates. Let's go and do the same thing for the other one. Let me go and clear out the screen. Let's try another one here. Let's go ahead and take a look at these 2 points we saw earlier. -2, 3, and that's a 3 right there. Sorry about that. And 5, -1. All right. So let's go ahead and again let's go and plot them just to see what it should be, for example, right? So 1, 2, 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3. All right. So -2, 3 is up here, okay, and 5, -1 is down here. Okay. So the midpoint should be somewhere in this vicinity, then, right? If I did my calculation correctly. So let's go and calculate the midpoint. Let's find midpoint. All right, so let's go ahead and do that by averaging the x and y coordinates. So therefore, that's going to give me what? -2 plus 5 over 2. All right, average of the x's, average of the y's, 3 plus -1 over 2. And that's going to be what? +3/2 in this case, right? And this is 3 minus 1, so this is going to be 2 over. This will be 2 over 2, or +1. All right, so 3/2, I guess 1.5, right? So here's 1.5 and 1, right about there. So again, it looks like this is more accurate here. This is the midpoint there, as you can see. So this point that divides these 2 points in half if I were to connect them. All right, so hopefully we know the 2 formulas of distance and midpoint in this case. All right, let's go and finish out by recalling some concepts of graphing equations, because this being the xy coordinate system here, or rectangular coordinate system, you can write relationships between the x and y coordinates by having y equal to some formula in terms of x. So here's what I mean by that. Let's say I give you something like this here. Let's suppose I say that y is equal to, let's make it the absolute value of x. All right. Let's look at the absolute value graph, if you will. Let's go ahead and graph this. Let's graph this relationship here between y and x. All right. Well, one way to do it then is to make a table of x and y. All right. Now, to make a table, you're going to choose your x. Since y is in terms of x, then we're going to choose our x, any number we want, plug it in, and then figure out the y-coordinate. All right. So let's choose x to be, let's say, -2. Let's do 5 points. -2, -1, 0, +1, +2. Right. So let's find the matching y-coordinates for these x-coordinates, if you will. Again, how do we do that? Just plug it in. So that's the theme here for graphing these types of equations in this section. All right. Anyways, let's plug in -2. So all we're doing is what? Taking the absolute value of these guys, right? So what's the absolute value of -2? Well, that's just +2. So my first point is going to be -2 and +2. All right. Similarly, what's the absolute value of -1? Well, that's +1. So we're going to have -1, 1 as the second order pair. 0, absolute value of 0 is still going to be 0, so no big deal. 1, absolute value of 1, 1. 2, absolute value of 2, 2. Okay, that's pretty straightforward, I think. So we have these order pairs: 0, 0, origin, 1, 1, and 2, 2. Let's plot these 5 points and connect them and see what this absolute value of x graph looks like. Let me draw that right here. Okay, so here's y, here's x. All right. So let's go ahead and make a few marks on there. 3, 1, 2, 3, 2, 3, 1, 2, and 3. All right. So -2, 2. So -2, 2 is up here. All right. -1, 1. So -1, 1 is right here. 0, 0, the origin right here where x and y axis meet. 1, 1, and 2, 2. So you can see if I were to connect these points, a little bit tougher on the sketch pad, but you should get a V-shaped looking. Oops. If I connect this, a little tricky here. But yeah, it's going to be a V-shaped looking kind of graph. So this is the graph of the absolute value of x, y equal to the absolute value of x. All right. So again, all we'll do is what? Generating a table in the homework. The x coordinates will be given to you. Just plug it in to get the y coordinates. Let's go ahead and try another one. Let me go and clear out the screen. Okay, let's go ahead and graph. Let's graph y equal to something like x squared minus 1. All right, x squared minus 1. All right. Again, let's give you the x coordinates for this. Let's use make a table again, x and y. So I'm going to give you these x coordinates, and you have to plug it in to get the y coordinates. Right. Let's pick x to be 0. Let's pick x to be 1, -1, 2. And -2 again. So essentially the same x we had before, but you may get different x coordinates to plug in on the homework. All right. But anyways, just plug them in. Again, just plug it in. So 0. If I plug in 0 for x, 0 squared is what? 0 minus 1, -1. All right. Plug in 1. What's 1 squared? 1 minus 1. 1 minus 1 is 0. All right. Plug in -1, but -1 squared is also +1. So you get 0 again because you minus the 1 here. All right. How about 2? 2 squared is what? 4. 4 minus 1 is what? 3. Similarly, -2, that's +4 if I square it, -1, +3. All right? So let's see what the sketch looks like here on that. Now, it's going to look somewhat like the absolute value graph, but except it's more curvy. Here's what I mean by that. So it'd be a more smooth-looking curve, if you will, instead of the V-shaped graph we had earlier. All right, so 0, -1, here's that. All right, 1, 0, -1, 0, and 2, 3. So 2, 3, 2, 3, all the way up here, and -2, 3, all the way up here. But the graph's gonna look something like this. It's gonna be a little bit more curved because it's gonna be it's a square graph. Now, because of the x squared. We'll talk more about this type of function called a quadratic function, or a quadratic. This graph is called parabola later on in the course of the semester here. So let's go ahead. Let's finish the graph here. So this is y equal to x squared minus 1. All right. So again, if the x coordinates is given to you, just plug it in to get the y coordinates. All right. Not too bad. Later on, I may give you the y coordinates and ask you to find the x coordinates. That'll be a little more challenging, but we'll talk more about that later on. All right. For right now, that's all we have for you. Let's go and take a look at the problems I want you to work out and post into Blackboard for this section. Now, just a couple of problems here. Not too bad. Let's go look at the Blackboard problems here. All right. So number one, let's go ahead and give you 2 points: -7, -5. All right. And first point, second point is -2, -1. -2, -1, and I want you to find both the distance between them and the midpoint between them. So find distance, that's an S right there, and midpoint. So do both. Oops. All right, so find distance and midpoint. I find distance and midpoint here. I should maybe write that a little better. Sorry about that. Midpoint. All right. And number 2, on Blackboard, I want you to graph this. Not graph, but find the y coordinates. Basically, complete this table here. Find the y coordinates that matches the following x coordinates. Let's suppose y is equal to the absolute value of x minus 2 plus 3. All right. Absolute value equation here, if you will. All right. We'll talk more about that later on. But anyways, let's go ahead and complete this table for the following x's. All right. So find y. Find y for x equal to what? Let me give you these numbers: 0, 1, 2, 3, 4, and 5. All right. 0 through 5. Right, so find the y coordinates that matches these x coordinates here. Just plug them in basically and work it out. Right, and of course I want you to graph it too, but for right now, just find it. Kind of hard to post the graph on Blackboard, so just find the y coordinates. But you should know how to graph it as well, of course, once you find the y coordinates. All right, so take care then. Until next time.